Welcome to the next installment of Nye's Night Notes Triple N's. I'm coming to you live from a very sunny morning here on October 20th. So I just wanted to kind of celebrate that nice sun as we get into fall. We're looking at Chapter 1, Lessons 7 and 8, and the constant rate of change and slope. We began some notes yesterday during class. Might not have stuck so well, so that's why I want to make a video so we can get all this into our notebooks and understanding it. Here we go. Yesterday, set up your notes like this, please, so that you have the triple N's up top, constant rate of change and slope. Those are our topics, and then put today's date. Once you're ready with those, go ahead and hit play to continue. These were our notes that we had set up yesterday. This was on page 66, and you'll see that right down here. I know it's kind of hard to see, but that's page 66. And on those pages, I just wanted you to jot down those three things to have our rate of change or ratio of change that we're going to call ROC. We have it as a change in Y and change in X, or a change in dependent versus a change in independent, and we also call those unit rates. So we've had those notes. We'll reference those, but that's we want to make sure we have those taken care of already. If you haven't, go ahead and jot those down on page 66. If you can see them. If you can't, then we'll just get them there when you're in class. We talked a little bit about this yesterday, but in case you forgot or in case you don't remember, we're looking at the rate of change in tables. ROC you're going to see here, meaning rate of change. Notice that we have no symbols here, so right now you're just hearing me talk. And once you see those symbols again, then I have you jot some stuff down. When we're looking at tables, all we're looking for is how does each value change. When we talk about values, we have money and we have number. This is the number of cars. So here I'm asking how does each value change? And you'll see in the notes, this is right from our book, that every time the money goes up by 40. Every time the money goes up by 40, the cars go up by 5. So we have this change of 40 and this change of 5. This is this part I'm going to have you jot down in your notes. Then this is so only the things inside of this line here. I don't need you to copy down this huge graph, but just jot down this change in dependent over change in independent. We're going to kind of talk about what that means, and that's when you kind of writing your final rate of change. So when you're putting your numbers down, you need to know which is the dependent, which is the independent variable to allow yourself to be able to jot down that rate of change. To help us define what those terms mean, we want to know what dependent and independent mean. I just want you to jot these down quickly, quick definitions, and these are dependent, just refers to a change in a value that depends on another value. So the only reason that that value changes is because of something else. An independent value changes on its own, or it's not affected by any other values. If it's making changes, there's really no impact on it. It's just a change in itself. We'll go back to the previous table to show what's dependent and what's independent. But just know that a dependent value, when it changes, it must rely or depend on something else. So get those two jotted down, hit play when you're ready to rock, and we're ready to go back and look at that table to see what's dependent and what's independent. Now that we're back at this table, we want to know which of these values, and we're not talking values, we're talking money or number, which is dependent and which is independent. If I'm thinking about this whole situation, this requires just a little bit of thinking about the story here. We have a car wash, and based off the number of cars, we have a number of dollars. So if 5 cars come through, it costs $40. If we have 10 cars come through, it costs $80. 15 for 120, 20 for 160. What I'm seeing as dependent is this money. The money is dependent on the number of cars. The cars, we have really no control over how many cars come through the car wash. So that's independent. What we can rely on is that we have this money depends on how many cars come through that car wash. So if I'm going at my ratio of change in dependent over change in independent, my change in dependent variable, which is my money because it depends on the number of cars, is 40. And then my change in number of cars, which is my independent variable, is 5. So I write it as 40 over 5, and that is my rate of change. Now if we're looking at rate of change in graphs, this is what we practiced in class yesterday, and I think my point was a little bit missed as to what you should be looking for when talking about your rate of change in graph. In every graph, you're going to see a relationship, and you're going to see the graph and the data represented by a line or a set of connected points. When you're looking for the rate of change, you're just asking yourself, okay, what's happening between 2 points? So really quickly, I'm going to have you can go ahead and hit pause whenever, and I'm going to have you jot down the stuff to the right of this line. So all of this stuff goes in your notes. Don't record the graph, that's just fine, but I do want this rate of change in graphs and all this information here written in your notebooks. When you're ready, go ahead and hit play again, and I'll continue talking. When you have these jotted down in your notes, kind of talking through what these steps are, you're just going to, first, you just want to pick 2 points on your graph. So if I'm asking you to find a rate of change in a graph, just pick 2 points. And so here I just want to get a different color. I'm going to select black. And so I wanted to pick 2 points. Let's look at this point and this point. They can be any of the points on the graph. I have 4 to choose from. I could have selected this point, but I didn't, and I could have selected this point as well, but I didn't. So right now I'm just going to focus on these 2 points, and we're going to look at, now we're going to see how I can find that rate of change. So pick 2 points, done. I'm going to cross that one off. So next we're going to go and give directions from the first point to the second. We always read graphs from left to right, so this is my first point. Come on, get away from there. This is my first point, and this is my second. So I want to give them directions from my first to my second. And once I have those directions, once I at least know what to do, now I'm going to look for the change in units vertically. So that's my change in my y. So now I'm looking to see from this point, how much do I need to go up the y-axis in order to be right in line with my next point. And it looks like I need to go from 72 to 144. So from 72 to 144. And I just need to calculate that quick to figure out the difference. 144 minus 72. And I get 2 borrow 7. I get 72. So my change in y is 72. Then I need to look for my change in x. So now I need to go from this point. I'm already up here. I rose up to this level. Now I need to get over to this point by moving along the x-axis. I go from 6 over here to 12 here. I'm kind of counting where I am on my x-axis. From 6 to 12. So I'm looking at that difference again, and again, I'm just looking for difference, so 12 minus 6 equals 6. Therefore, I know that my change in y, or my change in x, equals 6. And now I'm done with that part. Now I can just represent this as a change in y over a change in x, which my two numbers were just taking out those differences, 72 over 6. And now I have my rate of change. For every 6 minutes, which is our time here, for every 6 minutes, we gain 72 pages printed. For every 6 minutes, 72 pages. So that's my rate of change. That's how often this graph is changing. The final thing that we're going to cover in this video is just slope. And I am going to have you jot this down. So I'm going to put out our symbols here for including these in our notes. I don't need the graph included, so right now we're just going to put in everything into our notes, just this big sentence up top, that slope equals a simplified rate of change. All you're going to see in this slope is you're going to see some different language, and that's called rise over run. That might help you remember what change in y over change in x means. Rise just means we're going to rise vertically from one point to the next, and run means we're going to run horizontally from one to the next. So if I'm looking at these 2 points that are shown in the picture here, I'm looking at, this one would be 3:15, and the one I'm going to go to is 5:25. And so now I'm just looking for how much do I go up and then how much do I go over in order to get to that second point, and giving myself directions. So first I need to rise from 15 to 25, and that is a rise of 10 because 25 minus 15 is 10. So my rise equals 10, and my run equals from 3 to 5, that's a change in 2. So my change is 10 and 2. And now I have 10 over 2, but I do need a simplified rate of change. So now I'm just reducing 10 over 2 to 5 over 1. I'm dividing by 2 because I can pull 2 out of both of those numbers. So dividing by 2 to get 5 over 1. 5 over 1 is my actual slope. And so slope is just a simplified rate of change. So we're going to do a bunch of stuff today that deals with slope and rate of change, and these are the things we're talking about. To end our day, we need our really corny joke of the day, and our joke is, what is orange and sounds like a parrot? What is orange and sounds like a parrot? It's a carrot, orange, and sounds like a parrot. Jot down a carrot into your notes to know that you watch these, and have yourselves a great day. Adios, ladies and gentlemen.